In triple alpha, we have three programming languages, hydrogen, helium, and beryllium, that allow you to program at different levels of abstraction. Hydrogen is our gate-level language, where you'll use the commands defined in your instruction set. When we target hardware, we use a restricted form of hydrogen for circuits, which we'll describe in this video. Each line of hydrogen code that addresses quantum hardware consists of two parts. Firstly, there is a command that acts on the quantum system. It is composed of the command name, and then, depending on the command, is optionally followed by the parameters it takes and the addresses of the quantum subsystems, qubits or qudits, it acts upon. Secondly, you can assign a single variable or list of variables to store the output of a command if the command produces a measurement result or initializes a new quantum subsystem. Variables can be of two types: a subsystem address or a numeric value. In this example, the command qubit creates a new subsystem. The variable A becomes the address of the new qubit. You can directly address physical qubits through qubit binning. To do this, assign a qubit to a variable beginning with an underscore and followed by the target qubit's numbering from the processor's connectivity graph. You can mix pinned and dynamically allocated qubits in the same program. The measure command is an example of the assignment of a numeric variable. This command measures the state of a two-dimensional subsystem, and the measurement produces classical information as an output. We store the measured state as a numeric variable m. You can act on a subsystem by entering its address next to the command. You can also act on a list of subsystems. Here are two examples, one applying a Hadamard operation on a qubit at the subsystem address A, and the other applying a CNOT operation on a list of subsystem addresses A and B. If your command is a parameterized gate, you add the parameters separated by a comma in parentheses between the command and address. An example of this gate is a state rotation around a certain axis. Displayed are three examples. For the sake of brevity, please feel free to pause and examine them further. In the next video, we'll learn more about using the different features of our hydrogen programming language, such as assigning classical variables and arithmetic and using arrays and control flow elements.